You ever look up at the night sky and wonder, are we really alone? Well, what if I told you scientists might have just picked up a chemical signal, a potential hint of life, coming from a distant water world? Yeah. So let's get into the incredible and kind of complicated story of exoplanet K2-18b. Okay, first things first, let's just try to wrap our heads around how far away this place is. We're talking 124 light years. To put that in perspective, if you could somehow travel at the speed of light, the fastest speed possible in the universe, it would still take you 124 years to get there. It is just mind-bogglingly far away. And what's waiting for us at the end of that impossibly long journey? A world straight out of science fiction. Scientists think this isn't just a planet with oceans. It might be a planet that is an ocean. One single, vast, global ocean covering the entire surface. But you know, the water alone isn't what has everyone so excited. The James Webb Space Telescope, our incredible eye in the sky, was basically, well, it was sniffing this planet's air from 124 light years away. And it picked up a scent, something unexpected, a really mysterious chemical signal. Now here's the kicker. This is a chemical that, here on Earth, is only made by living things. Period. So you can imagine the question that just electrified the entire scientific community. Could this actually be a sign of life? So to really get why this is such a huge deal, we need to properly introduce the star of our show, planet K2-18b itself. So K2-18b is what we call a super-Earth. It's not just a little bigger than our home, it's about 2.6 times wider and a staggering 8.6 times more massive. I mean, this is a whole different beast of a planet.
And here's the really crucial part. This huge planet just happens to be orbiting its star right in the Goldilocks zone. You've probably heard of it. It's that perfect sweet spot where it's not too hot, not too cold, but just right for liquid water to exist on the surface. And, liquid water, that's the one ingredient we think is absolutely essential for life.
So how did we even find this place to begin with? I mean, how do you even start to study a world so far away? Well, the journey to understand K2-18b is like a great detective story, and it's been unfolding for years.
The first clue dropped back in 2015. NASA's Kepler telescope was just staring at a star, and it noticed its light dipping by a tiny, tiny amount, just 0.028% every 33 days. That's the classic calling card of a planet passing in front. Fast forward to 2019, the Hubble telescope took a closer look and made a huge discovery: water vapor in the atmosphere, a first for a planet in the habitable zone. But oh man, the real bombshell came when the James Webb Space Telescope turned its powerful gaze on it. And what the JWST found was so wild, it didn't just suggest there might be life, it actually forced scientists to invent a whole new category of planet, one that could be an ideal place to find it. This new type of world is called a Hycean world, a term coined by Professor Niku Madhusudan's team over at Cambridge, and it's actually pretty simple. It's a mashup of hydrogen and ocean. So you've got a deep, global water ocean covered by a thick, hydrogen-rich atmosphere. Suddenly, we had a whole new type of world to hunt for life on. And listen to this. This part is just wild. On Earth, all of our oceans, rivers, and ice caps make up a measly 0.02% of the planet's total mass. It's almost nothing. But on K2-18b, scientists think water could make up almost 50% of its mass. Think about that. It's not a rocky planet with some water on it. It's basically a giant water world with a rocky core. Okay, so let's get to the juicy part, the big one. The potential smoking gun that the JWST picked up. The signal that could, just maybe, change our understanding of the universe forever. So you're probably wondering, how do you even do this? It's genius, really. As K2-18b passes in front of its star, from our point of view, the starlight shines through its atmosphere. And the molecules in that atmosphere, things like water or methane, they absorb very specific colors or wavelengths of that light. So what's left is like a barcode, a chemical fingerprint, and the JWST is an absolute master at reading those fingerprints. And in the atmospheric fingerprint of K2-18b, it found a faint but possible trace of a chemical called dimethyl sulfide, DMS for short. Okay, so dimethyl sulfide. Why is that one chemical name sending shockwaves through astronomy? Well, here's why it's a BFD. On our planet, DMS is only made by life. It's an organic compound, and the main source is marine life, like phytoplankton in the ocean. Here's the most important part. We don't know of any natural, non-biological process that makes this stuff in large quantities. So on Earth, if you find DMS, you've found life.
But this is science, right? And in science, an exciting claim is never the end of the story. It's the beginning of a whole lot of skepticism, double-checking, and intense debate. And that's exactly what happened here.
And here comes the plot twist. As other scientists jumped in to analyze the data, and as the JWST took more looks, that DMS signal got weaker. In fact, it got so faint that it wasn't considered statistically significant anymore. It might have just been a random blip in the data, a bit of instrument noise. Suddenly, that potential smoking gun was looking a lot more like smoke and mirrors.
So this, of course, kicked off a huge debate. You've got the optimists on one side saying, hey, wait a minute, the planet still has methane, CO2, and water, all great signs. And that weak DMS signal, maybe it's still a hint. But then you have the skeptics on the other side, and they're pointing out that this planet might not even have a solid seafloor, that the DMS signal was almost certainly an error, and that the atmosphere could be so dense and hot that life as we know it would be crushed and cooked instantly.
And really, it all comes down to that famous idea from the great Carl Sagan. Extraordinary claims require extraordinary evidence. And finding life on another planet? That's about as extraordinary as a claim gets. The evidence has to be absolutely rock solid. And right now, for K2-18b, it just isn't.
All right, so let's just take a breath and recap what we know for sure. Water vapor? Confirmed. Methane and carbon dioxide in the atmosphere? Confirmed. That DMS signal? Totally unconfirmed, still up for debate. But here's the thing that's not up for debate, and it's super important. The idea of the Hycean world itself. That's a new, solid prototype for a potentially habitable planet.
And honestly, that might be the biggest takeaway from this whole story. Even if K2-18b turns out to be totally lifeless, it's taught us something profound. It showed us that maybe we shouldn't just be looking for another Earth. Maybe we should be looking for these Hycean planets, these big, waterlogged worlds that might be way more common out there in the cosmos. It has completely widened the goalposts for where we might find life.
Look, the story of K2-18b is a perfect example of how science really works. It's about thrilling discovery, but it's also about debate, skepticism, and yeah, sometimes disappointment. But it always pushes us forward. That planet, 124 light-years away, is now a giant question mark hanging in space. And it's an incredible reminder that our search for answers, it's really just getting started. So you have to wonder, what else is out there?